Welcome to the Health and Wellness channel. Here we empower individuals to lead healthier lives by providing the most potent and actionable science-based tools for mental health, physical health, and performance. A key foundation of health and personal growth lies in understanding how the brain adapts and evolves. The brain is not a fixed organ. It is highly adaptable, capable of rewiring itself in response to experiences, learning, and even intentional effort. This remarkable ability, known as neuroplasticity, is what enables us to acquire new skills, break bad habits, and enhance cognitive function at any stage of life. Let's begin by exploring the understanding of neuroplasticity, the brain's ability to change. We will uncover the mechanisms behind this powerful process and how you can harness it for continuous growth and improvement. The brain's capacity for change. Most people have heard of neuroplasticity, the brain and nervous system's ability to reorganize and adapt. Unlike a static organ, our nervous system is designed to change. From birth, our brains are primed for learning. Initially, a baby's brain has broad, imprecise neural connections. This explains why newborns lack coordinated movement, speech, and fine motor skills. But as we grow, our experiences, whether through social interactions, language acquisition, or environmental exposure, shape and refine these connections, customizing our nervous system to our unique life experiences. Certain brain areas are built to be highly plastic, meaning they change based on experiences. These include regions responsible for vision, hearing, and sensory perception. However, other parts of our nervous system are wired to be stable, such as those that control our heartbeat, breathing, and digestion. These functions need to remain reliable to sustain life. How neuroplasticity changes over time. The myth of new neurons. Many believe that activities like exercise lead to the creation of new neurons. While some neurogenesis, birth of new neurons, occurs especially in early life, after puberty, the human brain adds very few, if any, new neurons. However, the good news is that even without new neurons, the brain remains adaptable. By creating the right chemical and environmental conditions, the nervous system can reorganize itself, making change not only possible but highly probable. The role of sensory experience in brain adaptation. The role of sensory experience in brain adaptation is fundamental to how we learn and interact with the world. Our senses, sight, hearing, touch, smell, and taste, provide the brain with constant input, shaping and refining neural connections through a process called neuroplasticity. Similarly, individuals who lose one sense, such as vision, often experience heightened abilities in other senses, like hearing or touch, as their brain reorganizes to compensate. This adaptability highlights how sensory experiences drive the brain's ability to rewire itself, enabling us to learn new skills, recover from injuries, and adapt to changing environments. In essence, sensory input is the fuel for brain adaptation, making it a cornerstone of lifelong learning and resilience. Awareness. The first step to change. The first step in neuroplasticity is awareness. Recognizing what needs to change, whether a habit, response, or new skill, signals the brain to prepare for adaptation. This initial recognition is crucial because the nervous system does not change simply due to experience. Rather, change occurs only when key neurochemicals are released. These chemicals strengthen or weaken neural connections based on what the brain deems important. The science behind brain change. One of the biggest myths is that every experience permanently changes the brain. While experiences influence us, the nervous system does not automatically rewire itself unless specific conditions are met. For adults over age 25, neuroplasticity requires focused attention and repetition to reinforce neural pathways. This principle was demonstrated in research conducted by Dr. Michael Merzenich and Greg Reckenzone at UCSF. Their studies challenge the outdated belief that adult brains are fixed and incapable of change. Understanding neuroplasticity empowers us to harness our brain's ability to adapt and improve. By applying science-based strategies, we can facilitate meaningful changes in our mental and physical performance. Whether learning a new skill, overcoming trauma, or refining cognitive abilities, the brain remains a dynamic, ever-evolving organ throughout life. In these experiments, subjects were required to press a lever whenever they detected subtle changes in the spacing of bumps on a rotating drum. These variations were extremely slight, demanding a high level of attention to discern the differences. Importantly, these participants were not braille readers or individuals with prior expertise in tactile discrimination tasks. The findings revealed that as participants focused more intently on detecting these changes and actively signaled when they occurred, their brain representations of their fingers adapted rapidly. This demonstrated clear evidence of neuroplasticity in fully developed adults. Depending on the specific training, participants improved their ability to detect either a decrease or an increase in the spacing of the bumps, highlighting the brain's remarkable ability to reorganize in response to focused effort and experience. To further validate these findings, the researchers conducted control experiments. In some cases, participants were asked to touch the bumps while simultaneously focusing on an auditory cue, such as detecting changes in pitch or tone, rather than on the tactile stimulus itself. The results showed that when attention was directed to the auditory signal rather than the tactile experience, plasticity occurred in the auditory cortex, but not in the tactile region of the brain. This finding directly challenges the common misconception that every experience we have alters the brain. In reality, only experiences that receive focused attention drive meaningful neuroplasticity. The brain does not change simply through exposure to an experience. It changes when we deliberately engage and concentrate on that experience. The question then arises, why does attention play such a critical role in neuroplasticity? Researchers, including Michael Merzenich and his team, explored this further and found a clear neurochemical explanation. The first key neurochemical involved is epinephrine, also known as adrenaline. In the brain, it is referred to as epinephrine, while in the body, it is called adrenaline. This chemical, released by the locus coeruleus in the brainstem, is responsible for heightened alertness and readiness to learn. Neuroplasticity requires a coordinated effort of multiple neurochemicals and processes to create lasting adaptations. The second critical component is acetylcholine, which is released from two primary sites in the brain. One source is the brainstem, specifically from a region known as the parabigeminal nucleus, or parabrachial region. Acetylcholine from this area helps direct attention by filtering sensory input in the thalamus, effectively acting as a spotlight to enhance focus on specific stimuli. The third crucial factor is acetylcholine released from the nucleus basalis of Maynard in the forebrain. When both sources of acetylcholine, along with epinephrine, are present, the conditions for neuroplasticity are fully activated. In this state, the nervous system is primed for change. Neuronal connections strengthen or weaken in response to the focused experience, leading to lasting alterations in brain structure and function. Extensive research has confirmed that when these three elements, epinephrine for alertness, acetylcholine for targeted attention, and nucleus basalis activation are combined, neuroplasticity is not just possible but inevitable. Understanding this mechanism is crucial for anyone seeking to rewire their brain and enhance learning, recovery, or skill acquisition. Now, let's shift focus to practical applications. How can we leverage this knowledge to create conditions that optimize neuroplasticity? One fundamental requirement is achieving a state of heightened alertness. Many people accomplish this through a combination of a good night's sleep and moderate caffeine consumption. Ensuring consistent, high-quality sleep is one of the most effective ways to enhance attention and learning capacity. Beyond sleep, individuals use various psychological strategies to maintain motivation and engagement. Some employ accountability mechanisms, such as publicly committing to a goal or setting up consequences for failure. For instance, a person might pledge to donate money to an organization they strongly oppose if they fail to meet their objective. Others draw motivation from positive reinforcement, dedicating their efforts to a loved one or a meaningful cause. By understanding and utilizing these principles, we can actively shape our brain's ability to adapt, learn, and improve throughout life. Neuroplasticity is not just a passive process. It is something we can intentionally harness to drive meaningful and lasting change. When we focus intently, the lens of our eye shifts, narrowing our field of vision into a small cone of high-resolution imagery, often called a soda straw view. This allows for sharper detail, but limits the broader visual field. If you want to learn effectively as an adult, you must be alert. It may seem obvious, but many people overlook the importance of knowing when they are naturally most alert during their 24-hour cycle. Identifying these peak periods can give you a significant advantage in learning. Protect this high alert time. Don't waste it on distractions, meaningless tasks, or activities that don't align with your goals. Your brain releases epinephrine more readily at certain times of the day, particularly during waking hours. Being aware of these natural rhythms helps optimize learning. Try maintaining focus on a fixed target, a piece of paper or a computer screen, for as long as possible while allowing necessary blinks. Communities that rely on intense visual focus often train this ability deliberately. Ultimately, improving attention is about harnessing cognitive mechanisms effectively. Some may prefer auditory learning over visual methods, whether due to low vision or because their subject matter is sound-based. The key is to develop attentional control suited to your needs. However, sustained focus all day is neither realistic nor beneficial. Even high-performing individuals don't remain in deep focus constantly. They take breaks, walking, cycling, or even idly staring into space. These moments of disengagement are crucial because learning happens in cycles. Our brains function optimally in 90-minute ultradian cycles. Within these cycles, focus naturally fluctuates, so don't expect uninterrupted concentration. The beginning and end of each cycle often include brief lapses in focus. How do you recognize when a cycle begins? Generally, your first 90-minute cycle starts upon waking, though it isn't exact to the minute. Over time, you'll become more attuned to these natural rhythms as you engage in structured learning. After a focused learning session, deliberate disengagement, such as walking, running, or simply sitting with a relaxed mind, enhances neuroplasticity. Deep sleep further solidifies what you've learned, making rest a crucial component of the process. And that brings us to the end of today's discussion on neuroplasticity. The brain's incredible ability to adapt and change. The key takeaway? Your brain is not fixed. It's constantly evolving based on your experiences, thoughts, and habits. Whether you're learning a new skill, breaking an old habit, or recovering from an injury, neuroplasticity proves that change is always possible. Many of you have very graciously asked how you can help support the Health and Wellness channel. The best way to do that is to subscribe on YouTube. You might want to also hit the notification button so that you don't miss any upcoming episodes. Leave a comment as well.